Today we are going to start our discussion on a very important topic known as functions. In this video, we'll look into the definition of function, one function, many one function, domain of a function, and range of a function. So let us start. A function is a rule that maps each x value to just one y value for a defined set of input values. For a defined set of input values is known as domain of the function. We will further discuss it in a while. We can also say that a function is a relation that uniquely associates member of one set with the member of another set. So let us look into few examples for a function, and these functions or these examples you can find them on your scientific calculator as well. X square, for example, this is a function. Under root x is a function. Cube root of x is a function. Similarly, we can say that 1 over x is an example of a function. Now for each function we will have an input value which gives us, and when this input value is inserted into the function, this function will produce an output for us. For example, for the first function, if our input value is 2, we get our output equal to 4. Similarly, if we have an input value, say for example 16, the output value is plus minus 4. Similarly, 27 is the input value and the function is cube root of x, that will give an output of 3. And if our input value is 5, the function is 1 over x, so our output will be 1 over 5. So these are few examples of function. Sometimes a given relationship is simply a relationship and is not a function. To check that whether a given relationship is a function or not, we can perform a test known as vertical line test. Vertical line test. For example, if I have a function or a diagram of a function, something like that, for example. Now if I draw a vertical line, I can see that this vertical line intersects the function at more than 1 point. If this is the case, that the vertical line intersects the function at more than 1 point, then this example is only a relationship and is not a function. Okay. Similarly, let's say if we have a function or the diagram of function like that, and now if you perform the vertical line test, you can see that the vertical line intersects the function at a single point. Wherever you draw it, it will intersect the function at a single point. So this is an example of a function, while this is not a function, this is just a relationship. So it is an important test. You can perform this one in order to verify whether a given diagram is a diagram of a function or not. A function can be a one function or many one function. Let us discuss both of these one by one. First of all, one function, also known as one mapping. A one function has one output value. When we say output value, it means y values or the values of f of x. A one function has one output value for each input value, and input value are the x values. So this is a one function or a one mapping. For example, if I say fx is equal to x plus 2, this is an example of a one function, because if we take any value of x, for example if x is equal to 3, then our f of 3 is equal to 3 plus 2, which is 5. So there is one input and which gives us a single output. Similarly, if x is equal to 4, we get fx is equal to 4 plus 2, which is equal to 6. X is equal to 5. Fx, or we can also say y is equal to fx is equal to 5 plus 2, which is equal to 7. We can also display a 1-1 function or 1-1 mapping in the form of sets. For example, if we have, this is the x values, which are 3, 4, and 5, and these are the corresponding y values, which are 5, 6, and 7, and you can see that each value exactly maps onto one single value. Many-one function. A many-one function has one output for each input, but there are outputs or y values that have more than one input, that is x values, mapped onto them. So this is the difference between a 1-1 function and a many-one function. For example, if we have a function, say a quadratic function, and in this function we can say that for a certain value of y, say y is equal to 2 for example, you can say there are more than one x values. So this is an x value for which y is equal to 2, and this is another x value for which y is equal to 2. So this is an example of many-one function. For a single y value, there are more than one x values. Similarly, we can also have another example of a, say, cubic function, say this one. And in this function, you can see that for a single y value here, this is a y value, we have 1, 2, and 3 x values. So this is also an example of many-one function. Let's have a look into a couple of examples. In first example, our function fx is equal to 5 minus 2x, and it is defined for x is between minus 4 and 5. We need to work out the domain of this function, and we have to sketch the graph of the function and also find the range of the function. So first of all, the domain of the function. Domain are the x values for which the function is defined. So here we are. This is our domain. So our domain is x is between 5 and negative 4. In order to sketch the graph of the function, we have the function y is equal to 5 minus 2x, and rearranging this one we'll get y is equal to minus 2x plus 5, which gives us that there is gradient negative 2 and y-intercept is 5. Now we can sketch the graph of this function. Straight line crossing y-axis at 5 with a negative gradient, so should be something like that. Now we need to work out the range of the function, and a range of the function can easily be found out or worked out from its domain. The minimum value in domain is minus 4 and the maximum value in the domain is 5. So our function is y is equal to 5 minus 2x, inserting the value 5 minus 2 into minus 4, which gives us 5 plus 8 is 13, and when x is equal to 5, then y is equal to 5 minus 2 into 5, which gives us 5 minus 10, which is minus 5. So x is minus 4, y is 13, and x is 5, y is minus 5. You can also show these points on your sketch. So minus 4 and 13, this is minus 4 and 13, and this is positive 5 and negative 5. So this completes our sketch now. This is the y-intercept, which is 5, and gradient is minus 2. Therefore, range of the function are the corresponding y values. This is the value of y when x was negative 4, and this is the value of y when x was 5. So y is between 13 and minus 5. In this example, the function f(x) is equal to x minus 3 whole square plus 8, and it is defined for the values of x between minus 1 and 9. So this is our domain. We need to sketch the graph of the function, and we have to work out its range. So in order to sketch the graph, we need the points of vertex and the orientation of the curve. Clearly, x minus 3 whole square is always positive, so therefore the orientation of the curve will be like that, and it will have a minimum point at its vertex. So y is equal to x minus 3 whole square plus 8. This is the y value of vertex, and from here we can get the x value. X minus 3 is equal to 0 gives us x is equal to 3. So vertex is at 3 and 8. So if I now sketch the curve, 1, 2, 3, and somewhere at 8, this is the vertex, and we can have the curve like that. Now we need to work out the range of this function. So our function is y is equal to x minus 3 whole square plus 8, and the function is defined for x is less than or equal to 9, greater than or equal to minus 1. So when x is equal to minus 1, y is equal to 24, inserting the value of x here. And when x is equal to 9, y is equal to 44. Therefore, the range of the function is y is between 44 and 24. That is our answer. You can also display these points on your curve. So x is minus 1 and y is 24. So this is the point minus 1 and 24. And when x is 9, y is 44. So this is the point 9 and 44. That's all for now. See you next. Take care.